last week, and I didn't watch the videos in class. I tried to look online to find like an online version.
You wouldn't be able to.
Okay, I don't have it.
You can either borrow mine or you can just copy the answers from someone if you trust them.
Okay, I don't have. Is that all right if I don't have it today?
Yeah, it's all right.
Okay.
Do you have a hole puncher?
Yeah, it's behind me. One of these things.
From last time.
So, kids, here comes Sarah to stamp your 4.4. You'll, a couple of the questions you couldn't answer, obviously, since we didn't get to watch one of the films.
Like writing.
Whoa. Yeah.
What's like this instead of doing like the whole page?
Yeah, that's
Well, it's just that it's hard to tell. It's hard to see if it's the whole thing. Like 8:05, 7:05, 3:06.
There's other ones in there, too.
I feel like we're going to spam.
Those probably don't line up with your regular. But no.
One from last time. Yeah, that's what I'm talking about. For what? Soil Lab 3. The Soil 3 Lab.
Okay, kids. I am sorry that I was late, but we got to get started. I'm still waiting. First of all, I'm sure that in my absence you've all completed your warm-up and that you've updated your good bad list if you didn't have all the stuff on it. There's a paper in the back that I'm sure everyone grabbed on their way in because you don't suck at life. It's the handout for the soil lab that I was telling you about yesterday. I think I mentioned yesterday that this was on the internet, so some students already did the lab prep. But this lab prep is due tomorrow. I'm sorry to give you overnight homework. I did talk to the class yesterday about why I try to avoid that. I'd like to look at that paper with all of you now, please. On the front, you'll see it says Part 1. And on the back, it says Part 2. But I got to avoid some confusion. Please look carefully at Part 1, which is on the front. You'll notice that 1 through 4 are for the first day of the lab, and 5, 6, 7 are for the second day. Because this is a 2-day lab, the pre-lab is worth 2 points, making this a very high-stakes assignment. This is roughly 2 units worth of warm-ups or 2 labs worth of pre-lab points. In other words, it's a high-stakes assignment. Don't blow it off. You'll need the full procedure for both parts. You can cut out the soil triangle if you'd like to,
No, I was done.
and then just glue it or tape it onto your paperwork. And please look at procedure point number 1. Read number 1 in the procedure for part 1. You'll need to bring 2 cups of soil. Do not take dirt from the school, and definitely do not take dirt from my school garden. Believe it or not, for many of you, dirt looks like dirt, but I recognize our garden soil from like 100 miles away. I won't believe you if you tell me that's the dirt you have in your neighborhood because I know the difference. Also, trampling our garden is not helpful. So please don't trample our garden. Please bring dirt from home. Do you remember that when we make a change? When you write a new number, you gotta put a little zero above it. Make sure that you're on number 2 or a couple of those numbers. So definitely, no matter what, don't take dirt from my garden here in the classroom, here in the school. And for many of you, digging up dirt won't be easy in your house. A, if your house truly has no dirt, you're welcome to pick on your neighbors. B, if your dirt is very exposed, it'll be caked and hard. So what I would recommend is that you find dirt under mulch. Either underneath the leaves below a tree, or underneath a bushy plant that drops leaves often. But you want to find like 3 or 4 inches of mulch, scrape that out of the way, and then your dirt should be pretty easy to dig. Don't forget, underneath that mulch, you have a lot of biological activity, which keeps the dirt fluffy and soft. So if it's difficult for you to excavate around your house, look underneath naturally occurring mulch. Are there any questions about that? Yes?
I think I have like a lot of dirt that we were using at my house to make a vegetable garden, like excess dirt. Can I just take it from that, or does it have to be from the ground?
Most of that dirt is not naturally occurring, and it won't work for this lab.
Okay.
So do not use bag packaged or professionally produced dirt.
Cool.
That wouldn't work for the soil lab.
Well, it's a topsoil from like a stone's place.
This is an example of commercially produced soil.
All right.
Nick?
What about, like, I don't know, commercially approved, you get one that has been like 10,000 for years.
Probably that would be fine. Yeah, I mean, if it's been in the ground for a long, long time, it's probably become natural dirt by now, even if it didn't start that way.
So vegetable garden is
Kind of depends. Like, I've seen where Bill works over at the ranch, like that seems pretty legitimate dirt.
fine. I was just at my house. It's probably not.
You know, it just depends how young the dirt is. Most of the dirt you buy from a store is compost,
Yeah.
and compost won't work for this lab.
Okay.
If the compost has been blended into dirt for a while, then it might be more usable, but ideally you want to use the wilder dirt if you can.
Okay.
Questions about that? I have a trailer to show you for tonight's after-school film. It's at 6 p.m. and it's awesome. It has unbelievable footage of fish. But like I've told you before, global fisheries are in a really steep decline. So the movie is beautiful because of the stunning footage. It's really eye-opening because of the excellent science. And it's really depressing because of the bottom line. Also, if you thought that commercial fishermen were gentle with fish, you might find it disturbing that some fishermen don't necessarily baby their fish. Technically, they catch the fish knowing that the fish will be dead very soon. And so most fishermen don't really baby them. If you're going to be bothered by this, you may not want to watch the movie because there are a couple instances of people being, what's the right word? Harsh, not gentle with your seafood. There is some gaffing. Spearfish are really dangerous when you get them on the deck. And so usually you have to kill them. On some boats you can shoot them with a gun. And sometimes you just club them, to kill them. But for a really big one, usually you have to club them with a sledgehammer.
Must be a really fun job.
Yeah, I mean, it's just part of fishing for this very dangerous fish. When you get a 12-footer of those on the deck, it flops around, it can kill you. So it unfortunately is handled very expeditiously by the fishermen. Yeah?
What is that word underlined underneath high on the bad side?
We'll go through it. If there's something you can't spell, I'll spell it when we get to it, but it's lighted.
Live visual.
The losing species, what does that mean for us? What does that mean for society?
What is the tuna that you serve? Which ocean is it from and how is it caught?
If you take those curves, well, they're dropping. When are they going to hit zero?
At one level, it's a question of how bad is it?
Send a shiver down my spine.
We have reached the limits of what the ocean is capable of providing.
It's a finite resource. There will be a point in the future where we will run out.
It's a question simply of when.
It could be an overflow return.
The sea belongs to us. So why don't we claim it back?
And that'll be tonight at 6 p.m. Very good movie. It's one of my favorite documentaries ever made. I've loaned this to friends of mine and colleagues and my parents, and I just think it's a good movie. But it's kind of heady, kind of depressing, kind of gnarly. Thought I'd give you a heads up.
It's the movie just about like exposing commercial fishing and saying that fish are gonna run out if we keep doing them.
Yeah, I mean, I think that the bottom line of the film is that we have to better manage the resource. Like, I love fish, and I love fishing, and I love fishermen. Like, I don't want everybody to, like, T.P. Hayden's house. I don't want everybody to, like, this isn't supposed to be polarizing against fishermen. It's just about how we're managing the fish. With better management, there would be more food for everybody. In many parts of the world, there is no management whatsoever. Just get out there and do whatever you want. So there is this, like, international industrial fishing that's really damaging. And I think the movie tries to open the public's eyes about that. So, kids, I'm torn about this. One of the most well-known Yosemite climbers is also a base jumper. And a couple days ago, he had a horrifying base jump accident. And because I was on YouTube looking for this trailer, I found footage of him right after he landed. And it's super grisly. But it's kind of amazing. There is like graphic close-up footage of this guy's exploded leg. Like,
That's what I call life.
If you don't want to watch it, go outside.
and so I gotta say this. I have to warn you. Like, honestly, I just think it's kind of gnarly and amazing, and I like getting hurt, and I like it when other people get hurt. So it's just interesting, and I know him, and so part of me is just like sad to see him get hurt. He is alive. They have reattached the foot.
Oh my god. Oh, is he never gonna climb again?
But it's really scary because I don't know what's going to happen. He's a professional rock climber, so this really threatens his career.
Sucks, dude. Have you ever seen? I forget what his name is. It's kind of like it sounds like a European name. He's like the best squirrel shooter in the world.
Does what? Squirrel shooter?
He like does free like.
I've seen a lot of that.
Stuff.
Yeah.
You might have seen the video. It's him like going down a canyon and hitting like balloons that are like 6 feet off the ground, and so he goes really close. But he was like squirrel shooting in South Africa in these crazy like rocky mountains.
Oh, and you hit one.
And his legs hit. How gnarly is that?
What you guys do?
Yeah, he
And
broke
he just tumbled
both of his legs, which is, and you have to like you're putting a lot of pressure on your legs squirrel shooting, and he gained control.
And you regained control, yeah.
Yeah.
And you flew away. Hey guys, so I just want to warn you, this is after the dude has hit the ground. What happened is he had a problem with his parachute. So when you base jump, if you're jumping off a cliff, you got to track away from the hill before you open the parachute, because when you open the parachute, it slows you down and you swing a little bit. You don't want to open the parachute when you're close to the cliff, because it could swing you into the cliff. And I haven't heard from him what happened. A couple people I know were in the neighborhood when it happened. And it sounds like he had some sort of parachute problem. I don't know if he hit the wall or if he hit the ground. But he was wearing a GoPro on his helmet. And so after landing, he stopped that previous recording, turned on a new recording, and says, "Oh, I'm bummed. I just hit the ground. This is so lame." And then turns the camera and it shows his foot. And it's totally mangled, so don't say I didn't warn you. Don't get me fired over this. I just think it's interesting.
Okay, yeah, Kyle will leave.
Oh, no.
Well, that didn't go good. I don't know if it's the brakes that just got redone.
Oh man.
Probably lost my leg.
Oh, she was off. What a boss, dude.
Pretty calm.
Well, he's in shock.
GoPros are off.
Thank you!
He also gets hurt a lot, so he's probably kind of used to that part.
Oh. Fuck.
I'm sorry about the profanity. I just remembered that.
Sorry, Mom. I lost my leg on that one.
Wait, is the shoe on his foot?
Yeah, she's
Okay!
Oh, so that's his cap.
Yeah, so it broke here.
Is he just waiting for someone to help him?
I have a
How did I get
feeling.
on there?
I have a feeling he is gonna learn if he can't rock climb. I feel like he's gonna learn how to rock climb with one foot.
Well,
It's gonna be awesome.
he has volunteered to work with this group of climbers that takes injured war veterans climbing.
Awesome.
So him and a couple of Yosemite guys, I forget the name of that group now, but they work with injured veterans to take them climbing. So he has already been like a leader in the adaptive climbing field, which is like a new thing. I heard this morning that they've successfully reattached the foot, and so now the next question is whether infection will set in or he can survive the infection. If he survives the infection, then it'll be what kind of functionality in rehab. I've just met him a couple times. He's not a friend or anything. He's just this dude that's been like, "Oh, hey, nice to meet you, man." But a lot of my homies spend more time in the valley. Like in Yosemite, I spend most of my time in Tuolumne, which is a separate part. But a lot of my friends that spend time down below in Yosemite Valley, they know him really well, and so a lot of people are kind of crossing their fingers to hope that he'll be okay.
He's gonna get a ton of fun
There's a
now.
clip on YouTube. I wish I could show it to you, and I wouldn't even know what to look up, but it's about this guy who jumped out of a plane skydiving, and he's got a GoPro on his head, and he starts pulling the parachute, but it won't deploy. So he starts freaking out, but and you can tell he's like panicking, he's scared, and then so he tries to do like the other parachute that he has, and then he realizes that none of them are going to work. So it's like him screaming and going through all this stuff as he's falling, and then like he hits the ground, and then like all these people rush to him, and the GoPro is still on, and like he's like talking, he's like, "Breathe for me, like call 911, my body's mangled, there's like this incredible, and it's just the vocals and just the audio of everybody around you, like you need to breathe and your body is gone, and now you're paraplegic, but you survive. And it's like this incredible thing. It's like he's in free fall, and he's like, you can like tell if he's breathing, and he's like screaming, and he's like kind of comes to terms with I'm gonna hit the ground, I need to brace for this.
Understanding
That sounds really gnarly.
No idea. I wish I could tell you.
That sounds really, really heady.
That's so crazy. He survived at what 13,000 foot.
Some number of thousands. Yeah. That was at a few hundred feet.
Huh? Have you ever skydived?
No, I was going to get certified the summer that my wife got pregnant.
Dang.
So that pretty much
Well shot.
put it all back in the jar, is what we say.
Is it heroin with Ion Powell?
Oh, really?
Yeah.
Those guys seem to be a couple.
They were for a second.
Oh,
They were like on the low key.
Oh, well, way to keep it on the low key there.
But-
All right. Yeah. Okay. So I don't know where we left off yesterday, 9 or 10 somewhere. Yeah. Check it out. I backtracked a little bit. So we already talked about some things that you've learned before. So one thing that you learned before from Unit 3 was the distinction about eating low on the food chain or high on the food chain. And realize what it means. Like in question number 1, where Chinese people are increasingly eating further up on the food chain, that has global implications. Then yesterday, we talked about Liebig and what most people describe as demand-based agriculture. So you start from 0 and then add with a bottle every missing ingredient in order. Demand-based agriculture. As opposed to a more ecological approach, what we call resource-based agriculture. And the secret ingredient, I think I told you, is humus, which is not hummus.
Is it as tasty?
It's even better. Then in number 10, the last one we discussed yesterday, the problems with monoculture. This should be review, because I think we did this yesterday. Did we?
Yeah.
So you get no diversity, it's riskier. You get what's called a nutrient burden, like one crop that keeps taking away the same nutrient. If you grow corn, one year it'll be like this, and when you grow corn next year, it'll be like that. When you grow corn the next year, it'll be like this, and the year after that, the corn won't even sprout. Because corn is like a sponge for nitrogen. After 3 or 4 years, you can't grow anything anymore. It's called a nutrient burden. Keep in mind also that this is a giant target for pests. Monoculture is really dodgy. Because the pests, once they move in, you can never get them away from there. Yes?
Well, how does, like, there are corn farms and stuff, like, how did it, isn't that a monoculture? Like, how are they so successful?
They're kind of not.
Really?
I mean, you can't do that without synthetic fertilizers. The only way to do monoculture is basically like this.
It's like the big people like that supply the giant companies that are like they bring in soil.
Almost everything that you buy at the supermarket was grown in a big monoculture. Almost everything. Compare that to what we call polyculture, which is planting a diversity of things. And you should know that the best way to do polyculture is what we call rotational polyculture. Anybody know what rotates? Polyculture is growing many varieties, like corn over here, and squash over here, and beans over there. But what's rotational mean?
Is it like in Food Inc. when the guy, I don't know if it's Food Inc., but where he like has crops grow and then has the cows come in and eat like the...
Not really.
Isn't it the same as crop rotation where like after like one season or whatever he'll switch the crops?
Yeah, you're growing the crops on different dirt. So corn is over here this year. Next year we'll put the corn over there. And grow some beans over here. So that the beans will recover the nitrogen that was used up by the corn. And the corn is going to grow really well over here because 4 years ago there were beans, and so there's still a bunch of nitrogen left in the dirt. when you have polyculture, you get a healthy diversity at every level. Above ground, underground, and soil ecology. You get a diversity of nutrient profiles.
Do they normally do like seasonal rotations too, or for like the different seasons of the?
Yeah, so you can still monoculture with seasonal rotation. So in the summer we grow corn, in the winter we grow beets. But next year if you grow corn, then beets, then corn, then beets, then corn, then beets every year, every summer you're taking out only nitrogen, and every winter you're taking out whatever beets like. So you can do a seasonal rotation and still be monoculture. Does that make sense? If your summer crop is always the same and your winter crop is always the same, that's still monoculture. And you can grow summer crops in diversity and then winter crops with diversity. But if you don't rotate them, then it's the same thing per little block. In that one corner of the farm, it was corn last year and corn the year before and corn the year before. So that's still bad. That's why I was saying that the secret is different crops being moved around each plot of dirt. So rotational polyculture is really the secret. Does that make sense? Anybody else want to ask me something about this? Because that was actually a really great question. I wish I'd thought of it.
Are these numbers corresponding with the numbers for our packet?
Yeah, so this is where you'll find each of these topics in your study goals. I'm assuming that you have more notes in the study goal. Okay, so if we're done with number 10, I'd like to move on to number 12 about genetically modified crops, this one. And remember that we're doing the good of genetically modified crops is number 12. Then, like Friday or Monday, we'll do number 21, which is the bad side of genetically modified crops, the fears about genetically modified crops. So, I'm going to assume you all did your homework, so you already know that genetically modified crops can be made to be more resistant to cold, or resistant to heat, or resistant to bugs, or to chemicals. You know that they've made plants that are resistant to herbicide. You know what herbicide means? It's a chemical that kills plants. Why would you want to make a plant resistant to a plant poison? That's right, it lets you kill all the weeds but not your crop.
Roundup herbicide?
Yeah, so there's what's called Roundup Ready corn,
Yeah.
where you plant the corn and then you keep spraying the corn with a plant killer. The corn itself is resistant to that chemical, but all other plants die, so your corn grows up with no competition, no weeds. Yeah, exactly. So that takes you into this model. You know, weeds are part of the diversity, and they support something which is ultimately probably good for you. A little bit of weeds is not a big whoop. Okay. We've made genetically modified crops that are extra nutritious. So there's this type of rice that has like 2,000 times the normal amount of vitamin blah, blah, blah. So I don't remember what specific goal was achieved by having vitamin-rich rice, but it avoids a disease that's common in refugee camps. So they use this thing called golden rice, and then the refugees have like a dietary supplement with their rice. We can also make stuff that grows more quickly through genetic modification, and that was all in your book, so I'm going to move on. But there's a few things that did not talk about in your book, like genetically modified plants that make medicines. You know, some of our medicines are extremely expensive. I've heard that there are AIDS medicines that are as much as $10,000 per month. You can imagine that's not really available to the majority of AIDS patients. And so what if we could grow those medicines? That might maybe lower their cost of production, perhaps. It might make it easier to distribute medications. because a lot of people don't like shots, but everybody likes strawberries. So if you could have like your strawberry polio booster, you know, you go to the elementary school and everybody eat a strawberry, and there you go, you got your polio booster.
With the crop food, they all have polio.
Yeah, I mean, you wouldn't want to superdose that kind of medication. And a lot of people have pointed out, like, how do you standardize your dosage? You know, like, you're not going to get exactly 200 milligrams. But, you know, like, fruit that lowers inflammation is a really good way to get sick children to feel less pain. And so if you have, like, fruit with a little bit of Tylenol in it, for, like, a child, that's a pretty good way to moderate pain. Maybe lower the cost, maybe improve distribution, maybe just a waste of time, I don't know. What about animals that grow human organs?
Oh, yeah, like sheep.
You know, like pigs are really close to humans. Their heart is almost the same as yours. It operates at the same heartbeats. The same rhythm. It tolerates the same pressure. Like when you're running a marathon, if there's a pig running next to you, you have the same heart rate and the same blood pressure. If you take your pet pig for a walk, you guys are going to be about as tired when you get home. So the idea is, you know, what if we could give that pig a human blood type, then we could cure all those people that are dying because they can't get a heart transplant? There's those like very rare blood types that are really difficult to find transplants for. But if we had like a strain of pigs for every blood type, then a lot of people could be helped in medicine that today cannot be helped. You guys know that like hundreds of thousands of people die every year because they can't get a suitable organ, right? For organ transplant, you guys know that's a really big problem.
Lou Reed died of the liver transplant.
Who?
Lou Reed. He died back in 27.
I didn't know that. I mean, I knew they just died, but I didn't know that was from a liver thing.
Yeah.
Because he needed a liver transplant?
Failed.
Now it's like a complication of surgery.
Ah. You know, maybe this road is wrought with peril, but maybe if he'd had access to more livers, it wouldn't have been as big of a deal. I don't know. I played Perfect Day nonstop on Sunday.
Yeah.
Yeah, like pretty much looped for hours. That song is so beautiful. You know, we've also talked about making algae that produces diesel and bacteria that produces hydrogen gas. So genetically modified species that produce biofuels. That would probably be really, really, really useful. You guys know that hydrogen fuel cells are extremely simple. The only challenge is getting the hydrogen, right? You guys know that? You can build a hydrogen fuel cell in like 15 minutes for $40. The challenge, of course, is getting the hydrogen, but not if you can make a bacteria that farts hydrogen. We'll come back to talk about the challenges of GMOs, but there are some promising ideas. And in number 13, I'd like everybody to read the question in number 13, please. Read the question for number 13, please.
How would one harvest hydrogen in the first place?
I'm not sure. It's a good question.
So number 13 says, will there be enough food in the future to support a growing... Will there be enough water to make enough food for a growing population? And there's a really simple answer to that. Hell no. There isn't enough water now. So I got to explain a little story. Back in like the 1920s and 30s, when we noticed that a lot of people were moving from the right coast to the left coast, we realized that California could be a really good place to grow food. And in the 1920s and 30s, we also got pretty good at engineering and machinery. And somebody had a really smart idea. They said, what if we use federal tax dollars to build an extensive network of canals and dams and reservoirs and plumbing so that we can provide farmers in California with very cheap water. If the water is cheap and we give away the land, they'll make really cheap food and support the westward expansion. Does that make sense? You know, cheap water means cheap food. Cheap food means everybody moves west and everybody's happy. Well, it worked. They built the most extensive irrigation network on Earth. It's called the Central Valley Water Project. The Central Valley Water Project was built using federal tax dollars, and then the water was basically given away to farmers. Farmers pay about 1/10% what you pay for water. About 1/1000th of what you pay for water. Most of you pay somewhere around a penny per gallon, give or take fractions of a penny. But a farmer pays about a penny per 1,000 gallons. And now think about it. If the farmer has a leak in the pipes and they got to pay a worker to fix the leaks, is it worth it? It's like Hannah is going to charge me $10 an hour to fix that leak for 3 hours. That's $30. I'm losing a penny a day in water. It's not worth it to fix the leak. If the cheapest irrigation wastes water, who cares? It's not like the water costs anything. So farmers use sprinklers because they're the cheapest. But a funny fact is that in most parts of the world, a sprinkler evaporates about 90% of the water before anything hits the ground. And most of the water that hits the ground evaporates before it reaches roots. So you use about 3 or 4% of your water for irrigation, and about 96 or 97% becomes water vapor. Who cares? The water's free. Not a big deal. But now that we're starting to run out, a lot of people have said, hold on a second. We need better irrigation, more careful management of the water supply. We need the right crops for the right areas, and we need real pricing. Farmers really should pay sort of what water costs, because we don't need to encourage any more new farming. We're already the biggest farming state in the United States. Do you guys know that California grows more food than any other state? And here's a wacky fact. Do you guys know that agriculture makes more money in California than Hollywood or Silicon Valley? Everybody thinks of California as like, oh, they're the, movie state or the technology state, but we are the lettuce state. Lettuce and strawberries. Okay, so some irrigation stuff for number 13 there. Questions about that?
Well, I don't understand how, if it's like evaporating, isn't it not, it's not disappearing, it's just going up and then it come back down?
Oh, so it's not leaving the planet. That's true. That's totally true. Like, it'll evaporate, make clouds, and fall somewhere else. Cool, bro. The problem is that water vapor might not fall anywhere near you, so locally your supply is still limited. All that you've got is what was dropped in your mountains, right? In your watershed, once you've wasted water, that's not going to make any more rain for you. The rain that became Santa Barbara watershed rain, that was probably water vapor over Alaska like 3 months ago. So sure, we can evaporate the water, and it's not going to leave the planet. The planet's not going to run out of water. But regionally, in the space where you are producing your food, you've only got a small percentage of the planet's water. And once the gods have graced you with that little bit of water, you should try to hold on to it. Because, by the way, it's not just for farmers. We need water for cities and for people. We need water for fish and for other ecological functions. And those fish have all sorts of cultural and economic consequences too. So it's not like we're worried about the planet running out of water, but regionally, you got to keep as much of it as you can. Yeah.
If it's so cheap for farmers to use water, why don't they invest money making like a more efficient way to water their plants without wasting the water? Because wouldn't that also save money? Or is it like it wouldn't save enough money for it to matter?
It just doesn't save enough money to be worth it.
Yeah.
Like, yeah, I can use drip irrigation, but it doubles my labor cost. So I save $40 on water at the expense of $3,000 in labor.
So what are a more efficient way to water besides sprinklers?
Well, drip irrigation is obviously by far that 10% evaporation.
What is that?
Drip, like drip tape, emitters that drip into the ground. And you can use different types of sprinklers, different timing of the day when you run your sprinklers. A lot of this stuff is really simple solutions, like use a moisture sensor instead of a calendar to water, so you only water when the dirt is dry. Like, that would seem pretty obvious. But a lot of times, like, the moisture sensor costs more than a year of water. We'll just water every day. Who cares? So by adjusting the pricing, some conservation measures start to make more sense. Not necessarily all of them.
What does it say next to wasteful?
Wasteful spraying and subsidized prices.
Spraying?
Yeah, spray.
What does it say between wasteful spraying and crop selection? Or in the boot?
Real pricing. Okay. Any questions on 4.1 at all? Anywhere in the assignment? Okay, 4.2 vocab. Vocab on 4.2.
I didn't get narrow or broad.
Okay. A narrow spectrum pesticide is very targeted, like just termites, or just beetles, or just that one species of aphid. It has a narrow spectrum, meaning that it's targeted. And broad spectrum pesticide is the opposite, a very generic, general kill pesticide. Who else? Any other vocab on 4.2? Okay, great. In number 14, this, what's it called? Steve Burr. He does one thing on his farm that you should really know about. He uses what's called rotational grazing. Now, a lot of farmers overgraze. They put the animals out in the field, and then they leave them until the green is gone.
That's what I was. This is when you said crop rotate or.
Got it.
Yeah, that's what I was
You were
talking
thinking
about.
of this one. So a lot of farmers will just say, good luck, cows, and they let them out. And the cows will eat all the grass, and then they'll eat most of the roots, and then when there's nothing left, you move the cows. But of course you realize that that land, where the grass has no green left, how's that plant going to recover if it has no photosynthetic tissues to provide energy? If you cut the plant all the way down to the dirt, where will it get the energy to grow? So instead, you let the cows come and thin out the grass a little bit, but while there's still some photosynthetic tissues, then you move the cows. So the plants have some greenery, they have a place to run photosynthesis, they recover faster, and you can bring the cows back faster. Here's a wacky thing. If this is one farm, and I fill it up with cows until there's nothing left and then get rid of the cows, that's probably their one meal for the day. Sorry, for the year. But check this out. If I take the exact same farm and I break it into quarters, I can use them to mow the grass a little bit, but while there's still grass left, I move them over here. And when there's still some grass left, I move them over there. And when there's still some grass left, I move them over there. And when there's still some grass left, I bring them back to this spot, and this grass is already recovered. So I might be able to get 2 rotations, or 3 rotations, or 4 rotations in 1 year on the same dirt, where I could have only fed them once if I let them get down to the roots. You see, here's the secret. Seasonal grazing or overgrazing gets no reseeding and root damage. But if you rotate, that avoids the root damage and protects reseeding. As long as the grass can drop some seeds, keep healthy roots, and keep growing after it's grazed, grazing is actually pretty sustainable.
So why don't all farmers do it then?
Because it takes more labor and because fences are expensive. Also because a lot of places, I mean, honestly, a lot of ranchers don't really care about the land. I'm not trying to be a jerk, it's just that they use public lands. So it's not like you're necessarily guaranteed you can come back next year. It's like, sure, we'll let you into the national forest, but it's a one-time thing. And so you don't have an investment for next year. You'll use it all up, because who cares? It's not open for you next year. So a lot of farmers don't have a guarantee that they'll return to that grazing land. And so as a short-term goal, this makes perfectly good sense. Fatten up the cows as quickly as possible, then move on. But if you're managing that grass for the long term, this makes sense. Anybody else? Did everybody hear her question? She says, why don't all farmers do the rotational thing? Okay. Number 15, I have a giant list. All this. Because number 15 was, what is the whole list of environmental impacts of agriculture? Well, there's a zillion environmental impacts from agriculture. Because in 16 we talk about erosion in particular. So this is all 15, and then these individual ones will break out somewhere. So in number 15, there was this big old list. Soil erosion and sediment transport, pollution from fertilizers and pesticides, pollution off the farm from soil and water and pesticides and fertilizers, deforestation and habitat loss, desertification, salinization, accumulation of toxic metals, shifts in the food web, and eutrophication. We're going to break most of these down later on. There's just a couple I wanted to talk about. One thing I wanted to talk about is this one. Remember that erosion is actually 2 problems. There's the loss of the soil up top, and then there's wherever you take that sediment down below. 2 problems. Loss of dirt from one place is erosion. Extra dirt someplace else is called deposition or sedimentation or sediment pollution. I also wanted to remind you about the water pollution, pesticide, chemicals things. Look, I'm not a defender of pesticides, but I want to make sure that you still sound like scientists instead of like chickens with your heads cut off. Who is harmed by pesticides? How?
In the past. Pretty, I mean...
No.
Oh, the runoff in the soil?
No.
Fish.
Yeah, people who drink the water near a farm, people who work on the farm, the ecosystems in and around the farms, the communities around the farms, all of those people are hurt. But not you, the consumer. And listen really carefully, because there's like a simple fact that you must know. You can't be a scientist if you don't know this one simple fact. Everything is toxic and nothing is toxic. The question is, how much dosage are we talking about? Like cigarettes, they give you cancer, and we know that. They're toxic. But if you have a single cigarette, you'll be fine. You're not going to get cancer. You can quote me on that. because the dosage is just not significant. Pesticide is super deadly, but the amount reaching you in your diet is not statistically significant. We got to be really, really clear about this. Pesticides don't really hurt you as a consumer. Can somebody remind me what I thought of pesticides when we come back to this on Friday or Monday? Write that down.
What if water is just a slow-killing poison?